Today we've got another graph sketch, and we need to sketch x to the 4 minus 2x cubed minus 3x squared plus 4x plus 4 by expanding x minus a squared times x minus b squared. Otherwise, well, let's start off by expanding x minus a squared times x minus b squared. So if we expand each bracket, so we've got x squared minus 2ax plus a squared multiplied by x squared minus 2bx plus b squared. Now, since we've got more than 3 terms in each bracket, more than 2 terms in each bracket, we should use the grid method. So if we draw that out nice and big, squared minus 2x x, and then we've got b squared as well. So x squared times x squared is x to the 4. X squared times minus 2ax is minus 2ax cubed. A squared times x squared is a squared x squared. Next we've got x squared multiplied by minus 2bx, so that's minus 2bx cubed. Minus 2ax times minus 2bx is 4abx. Minus 2bx times a squared is minus 2a squared bx. X squared times b squared, x squared b squared. I think it's better to write it as b squared than x squared. And then minus 2ax times b squared is minus 2ab squared x. And we've got a squared times b squared, straightforward. Now let's collect like terms. So for x to the 4, we've just got x to the 4, that's fine. Then for x cubed, we've got minus 2a minus 2b, and that's x. Well, we've got x cubed. Then for x squared, we've got a squared plus 4ab plus b squared x squared. For x, we've got plus minus 2a squared b minus 2ab squared x, and then our constant is just a squared b squared. So now let's compare our coefficients with what's in the question. So if you write x2, just write it red, so we've got x to the 4, x to the 4, that matches up fine. Minus 2 for x cubed, minus 3 for x squared. Then we've got 4 for x, for 4x's, and then our constant is just 4. So now let's set up some simultaneous equations. So we've got minus 2a minus 2b equals minus 2. If we factorize out minus 2 from our left hand side, we've got minus 2a plus b equals minus 2. A plus b equals 1, so we can label that equation 1. Now on to x squared, we've got a squared plus 4ab plus b squared equals minus 3. Is that right? Yep. Then, well, we know a plus b all squared is a squared plus 2ab plus b squared. So you can rewrite this as a squared plus 2ab plus b squared. We've got 2ab outside our brackets equals minus 3, which can be simplified to a plus b squared plus 2ab equals minus 3. Yep, that's fine. Can we get any more simpler than that? No, that's fine. We call that equation 2. And then equation 3, set that up. We've got minus 2a squared b minus 2ab squared equals 4. Factorize that at minus 2. We've got minus 2a squared b plus ab squared equals 4. Further simplify our bracket. So we have ab on the outside. We've got a plus b equals 4. Yeah, that's fine for 3. And then our last one is just a squared b squared equals 4. Meaning ab all squared is equal to 4. ab equals plus or minus 2. We need to figure out whether it's plus or minus 2. So let's start. Well, we've got equation 3 and 1 look quite similar. They both got a plus b, so let's go ahead and divide equation 3 by equation 1, which equals minus 2ab a plus b over a plus b equals 4 over 1, which is minus 2ab equals 4, ab equals minus 2 then here we can just write next to equation 4 ab equals minus 2. Now where does that help us elsewhere? Well, we can put this into equation. How does this help us? For ab equals minus 2. Well, let's sub this into equation 2. So we've got a plus b squared plus 2 minus 2 equals minus 3. A plus b squared equals 1, meaning a plus b equals 1. That just gives us the same result as the top, equation, right? So now, got to look elsewhere. Where can we go with this? We've got ab equals minus 2. We've got a plus b equals 1. So let's rearrange ab equals minus 2 for a. So we've got a equals minus 2 over b. Let's sub this into a plus b equals 1. So we've got minus 2 over b plus b equals 1 times through by b. So we've got minus 2 plus b squared equals b. Rearrange to get 0 on one side. So b squared minus b minus 2 equals 0. Factorize. So we've got b minus 2 times b plus 1 equals 0. Well, we've got b equals minus 1 and 2. So when b equals minus 1, a equals 2. When b equals 2, a equals, put that into here, we've got a equals minus 1. So essentially we've got a pair of solutions which are identical. We've got 2 minus 1. Let's sub that back into x minus a. Let's go on to the next page. X minus a squared, x minus b squared. So we've got minus 2 squared x plus 1 squared. Now we need to sketch this graph. So since we've got a square outside both brackets, we can sort of merge our brackets together and have only one square. So this would look something like this. So essentially we've got a quadratic all squared, so I think it's best to start off and draw a quadratic. So we've got x minus 2 and x plus 1. So we've got roots minus 1 and 2. We've got y-intercept minus 2. So that's 0, minus 2. We've got minus 1, 0. And we've got 2, 0 for a turning point. So if we quickly expand our bracket and differentiate, so we've got x squared minus x minus 2. So let's call that y. dy over dx equals 2x minus 1. 2x minus 1, our gradient function to 0, x equals a half. We sub that back into our original equation, we get a quarter minus a half, which is minus a quarter, minus 2, which is minus 9 over 4. So we've got turning point a half minus 9 over 4. So we've got the inside of our brackets all sketched. Now we need to square. Just go draw the sketches here. So our roots would stay the same. Anything in the negative will just become positive. Our y-intercept, well, we need to square our y value. So we have y-intercept 0, 4. We've got our graph will probably be a bit steeper. It's not probably, it will be. We've got minus 1, 0. Our y value for our turning point will be squared, so we've got 81 over 16. And then 2, 0 remains the same. Then from here onwards, the graph is just much steeper. So our sketch looks something like this. X minus 2 times x plus 1 all squared is the following. Hope you enjoyed that video and understood how I went about that graph sketch. Hope to see you in the next.